Hello, this is Mr. Collier, and today we're going to work with the formula for the nth term in an arithmetic sequence. Okay, so here's the formula to find the nth term in an arithmetic sequence. It says u sub n equals u sub 1 plus n minus 1 times d. So there's a couple variables here we need to talk about. First of all, this d is what we call the common difference. Okay. It's called a common difference. So let's take a look at a special arithmetic sequence like, let's say 5, 5, 11. So we're going to add 6 each time. 17, 23, 29, and so forth. So in this one here, the common difference is 6 because you have to add 6 each time. Okay, so that in this case here we have, in this particular sequence, we have d equals 6 because that's the common difference. You can get the common difference, and the reason it's called a difference is because you get this number by subtracting a term from the previous number. So if you do 23 minus 6, you get 17. If you do 29 minus 6, you get 23. If you do 11 minus 6, you get 5. That's why it's called the common difference. So the common difference here is 6. N, that stands for the term number. Okay, that's the term number. U sub 1 is the first term, and U sub n is the nth term. Okay, so in this particular sequence, this here, the number 5 is U sub 1, and then U sub 2 is the 11, and U sub 3 is the 17th, is the number 17, and so forth. So that's U sub 1, U sub 2, U sub 3, U sub 4, U sub 5. The d value is 6. U sub 1 equals 5 because that's the first term. And the n is the one that's constantly changing. N is a different number each time in the sequence. Okay, so how do you use something like that? Well, it comes in handy for several reasons. One thing you could do is you could find like the 100th term using your formula. Okay, so you don't want to write out 100 terms in the sequence. You can just use the formula to find the 100th term. So if it's a 100th term, that means n equals 100, and you'll have the formula u sub 100. That means the 100th term equals the first term plus 100 minus 1 times the difference, which is 6. Okay, and we can work that out. Now we know that u sub 1 is the first term. That one's going to be 5. So we really have u sub 100 is the 100th term is 5 plus, now 100 minus 1 is 99, plus 99 times 6. And we can work that out. 5 plus 99 times 6 is, so the 100th term is 2,970. Okay, so we can use this formula to find any term in the sequence, and we can also find some other things. If you're given, like for example, if you're given some of these other variables, and you can find the common difference or something like that. So we're going to do a couple more examples of these types of problems in a second here. Okay, this problem we have this sequence. We have 15, 21, 27, and so forth. So show that it's arithmetic. You want to find the d value, the common difference. So if you subtract these numbers, you're going to get 21 minus 15 is 5, or you could say 15 plus 5 is 21, or sorry, 6. Then you add 6, and then you add 6, and then you add 6. Okay, so that does show that this sequence is arithmetic, or you could just write down, you could do it like this: 39 minus 33 equals 6, 33 minus 27 equals 6, 27 minus 21 equals 6, and 21 minus 15 equals 6. So all the differences between successive terms is 6, so the common difference is 6. Okay, so therefore Here's how you write therefore. You can write this little triangle thing, triangle dot thing. Therefore, it is arithmetic. Now find the formula. Recall that the formula is, and this is in your formula booklet if you're taking math studies. U sub n equals u sub 1 plus n minus 1 times d. No need to memorize that. So it's u sub n equals u sub 1 plus n minus 1 times the common difference. So you get u sub n. Now u sub 1, that's just the first term, which is 15. And n minus 1, so we'll leave that as n minus 1. And the common difference is 6. And you can simplify that a bit. You can do, well, that stays 15. You can do 6 times n minus 1. You get plus 6n minus 6. And then you could do the 15 minus 6 gives you 9, or positive 9. So your formula is 6n plus 9. That's your rule. That's your general formula for finding any term in the sequence. Okay, so next question is find the 50th term, so we can use our formula to find that. So we have u sub n. So we have u sub n equals 6n plus 9. We're finding the 50th term. So the 50th term is u50. That equals 6 times 50 plus 9. So u50 equals 6 times 50 is 300 plus 9, which equals 309. 309 is the 50th term. Now next question, it says, is 87 a member? Okay, so basically, is 87 one of these numbers in the sequence? If you continue the sequence, do you get to a number 87? Okay, so in this case, this is not n. What this is this is u sub n. All right, this is the nth term. So we're going to say that u sub n, maybe there's a certain u sub n that gives you the value of 87. So we're going to test that and see if that's possible. So you just use the formula again, and we'll put 87 in for u sub n. So we have 87 equals 6n plus 9. And then we're going to find n, which term gives you 87. So you just solve this equation. Subtract 9 from both sides. You get 78 equals 6n. And to solve, you divide by 6. Okay, and I don't even need to work at the value. You should be able to tell, or oh, actually I can't. Yes, this is going to work out. So I am going to work at the value. 78 divided by 6 is 13. So 13 equals n. So the 13th term of the sequence is 87. So the answer, I guess, is yes. It is a member of the sequence. And the next one is same procedure. So you let 154 equal 6n plus 9. And let's see if this is possible. We're going to subtract 9 from both sides. And we get 145 equals 6n. So then you divide by 6. N equals 145 divided by 6. And you get 145 divided by 6 is approximately 24.166, repeating exactly that. So you don't get a whole number. That means that 157 is not a member of the sequence because your term numbers have to be whole numbers. So if you get a number that's not a whole number, then it's not going to be a member of the set. So you could say, therefore, 154 is not a member of the set. Okay, one more example. I think I've got some of these backwards here. Okay. Example 2, a sequence is determined by u sub n equals 4n minus 3. So here we have the rules all worked out for us. Then we're going to answer some of these questions. Show that it is arithmetic. That's going to be a little bit tricky. So what happens is, what you do in this case is basically you subtract successive terms. So what you can do is, you can take u sub n plus 1, that's like the next term, minus the current term, which is u sub n. And if you get a constant number, then you have a common difference and you have an arithmetic sequence. So we're going to basically take u sub n plus 1 minus u sub n and see if you get a constant number. So u sub n plus 1, well, u sub n is 4n minus 3, and u sub n minus 1 is going to be 4. Instead of n, we're going to have n minus 1. N plus 1, because this is n plus 1. So 4 times n plus 1 minus 3. So let's work that out. If you multiply in the brackets here, you get 4n plus 4 minus 3. Over here, you get minus 4n. And don't forget this is minus 3, so that's like a plus 3. Now if you work that out, the 4, let me just go to a different color. The 4n and the negative 4n cancel, the negative 3 and the positive 3 cancel. You're just left with 4, and that is actually the common difference. So if all your n's cancel out, and you get just a number, which is a constant, then it is arithmetic, and that's your common difference. Okay, so in the next question, I want to ask you find u1 and d. We already have d, so d is going to be equal to 4, which you found in part A. And now I can't see the question. So we're finding u sub 1, and u sub 1 is just the first term. So what you can do to find u sub 1 is you could just substitute 1 for n. That's just 4 times 1 minus 3. So u sub 1 is 4 minus 3, which is 1. So d is 4, u sub n is 1. And in the next question, find the 50th term. That's pretty easy. U sub 50 equals 4 times 50 minus 3, which equals 200 minus 3, which equals 197. Now, what is the least term greater than 90? So let's just check now to see if 90 is a term in the sequence. So let's check to see if u sub n can be equal to 90. Is 90 a term? So if 90 was a term, it would be equal to 4n minus 3. And we solve for n. We're going to add 3 to both sides. We get 93 equals 4n. And then we do n equals 93 divided by 4, which is equal to 23.25. Okay? So that equals 23.25. So that means that 90 is not a term in the sequence. Okay? But we have 23.25 for n here. So if you just round that up to 24, if you let n equal 24, then that will give you a number that's greater than 90. So if we use n equals 24 in our formula, and we put in, well, we find u24, that's going to be equal to 4 times 24 minus 3, which is, this is 96 minus 3, which is 93. So 93 is the smallest or the least term greater than 90. In the next example, I'm going to do this in a couple different ways. Firstly, we can do it this way. We know that we're adding a common difference each time. We'll call it d. So we're doing that once, twice, 3 times to get up to 13. Okay, so what happens is you're adding D, you're adding D again, you're adding a D again. So what you can do is you can say that 4 plus 3D equals 13 because you're adding that D 3 times. And if you solve for D, subtracting 4 from both sides, you get 3D equals 9. Divide by 3, you get D equals 3. So your common difference is 3. That means your next couple of terms are going to be 7 and 10 and then 13. So you can check your answer. 4 plus 3 is 7, plus 3 is 10, plus 3 is 13, so it works.